Okay, having seen some of that excitation-activation dynamics more clearly, we can start to explore this mystery that we encountered in our simulation. Why is the force produced by the biceps muscle maximized right here on our graph and not, out here? So to understand this, I want to start applying both the force length and the force velocity relationships. Let's recall first off the force length curve. So that says the maximum amount of force, and I'll write that out, force, that a muscle can produce is a function of its length. And that relationship should be something like this, roughly. So I have a little bit of an exaggerated drawing of the elbow flexion here. And I want to do two things. I want to compare what we might estimate the length of the biceps muscle to be in the current configuration that I have drawn, and also what that length might be if the elbow is extended out like this. So let's think about conceptually say the distance from here to here, because remember, we're modeling an entire muscle as just one big gigantic sarcomere. So if the muscle gets longer, then clearly that one big gigantic sarcomere gets longer. And for justifications on why that's actually a pretty sensible thing to do, there's some videos last week that explain it. So let's notice how when the elbow is flexed like this, the length of the muscle is here. And when the elbow is extended out like this, well, then the length of the muscle, maybe I'll do it in a slightly different shade of green, then the length of the muscle will be longer, right? So as the elbow gets more flexed, we're going to be moving from a longer muscle length, maybe somewhere out here or here, to a shorter one, maybe here. So one possible explanation of why we're getting more force here than here is that when we've flexed the elbow up to this point, the muscle fiber length is shorter than its optimal length. So maybe at the light green, we're here, and maybe I'll make it more clear, the dark green, because it can't be activation, right? Because the activation is basically 100% both places. So maybe that darker green is like there. One other thing we can think about is the force-velocity relationship. So let's try and recall what that was. We said that the maximum force production capability of a muscle is also going to be a function of its velocity, meaning how quickly this length is changing. And if you recall, that relationship looked something like this. And then there was also this interesting eccentric behavior up here. But for now, let's focus on the concentric part. Well, what does this curve tell us? It tells us that when the velocity of a muscle is 0, there's no detriment in its force production capabilities. But as the muscle starts contracting, starts shortening, then its ability to produce muscle force goes down. So does that align with what we saw in our simulation? Well, I think it does, because when the elbow was fully extended, the elbow wasn't moving, right? And so therefore the length of the muscle wasn't changing. Therefore its velocity must have been 0. But as we created force to start flexing the elbow, well, the length went from this long, right? Maybe that length. It went from that length to this shorter length. So in other words, it was shortening. So it must have had some positive velocity. So maybe the velocity was up here instead of here. So we could also consider a factor that might explain why the force production capability down here was smaller than up here, is that the not only was the fiber length shorter, but the velocity of the muscle fiber was faster. It was a concentric contraction. So that also decreased the force production capabilities of the muscle. Now, this is a very useful analysis to do because it explains some phenomenon that you are probably familiar with, which is when you're doing bicep curls. The most difficult part of the bicep curl for most people is getting started, right? It's like when if your upper arm is like this and your lower arm is like this, and maybe the dumbbell is here. It's getting started. That's the most difficult part, right? Once you get to here or so, things tend to be okay. And maybe we can explain that with when you're getting started, maybe the fiber length is too long, but there's one more piece to understand this, and then we'll have a full picture of why this mystery exists. We've kind of solved this problem, but there's one other thing that I want to talk about, which is the relationship between muscle force production and the production of torque at a joint. So we'll dive into that, although I think I want to make one more video actually plotting the fiber lengths and fiber velocities so we can check whether our predictions from this analysis were correct.